2.1 goes into functions and equivalent algebraic expressions. So number 1 asks to determine whether the functions are equivalent. So we have f at x and g at x. These are our two functions. Now looking at our functions, it doesn't really look like they are equivalent. I mean, they look quite different. However, if we break down these fractions to simplest terms, then maybe they will be equivalent. We're not really sure. So why don't we break them down to lowest terms first? And the way that we do that is we want to see if anything on the top, like the numerator, and the bottom denominator can cancel out. So just looking at g at x, I cannot cancel these x's out. You're not left with the answer 2 over 3. The reason why you can't do that is because the x on the top is technically being divided by everything, not just the x on the bottom. Just like that 2 is being divided by everything as well on the bottom. Okay, so you can't just take the x's and cancel them out. The proper way to do it would be to factor first. So see if something can factor from the numerator and from the denominator, and then cancel those greatest common factors out. Now taking a look at g at x, it doesn't look like it has a common factor on the top or on the bottom. So that's already in lowest terms. Let's take a look at f at x then. Maybe we can break it down further. So it looks like we have a simple trinomial on the top and a simple trinomial on the bottom. If we factor it out into the double brackets, we get x and x, that makes your x squared. Two numbers that multiply to -8 but add to -2, so -4 and +2. We're going to do the same to the bottom, so those two x's make your x squared. Two numbers that multiply to -12 and add to -1 are -4 and +3. Now that I've factored, I notice, oh, okay, so they do have a common factor, something on the top and something on the bottom. We can cancel those out now because we've already factored them out. So you're left with x plus 2 on the top and x plus 3 on the bottom. And what do you know? It looks exactly like g at x. So therefore, these two are equivalent. Let's try some more examples. Here's number 2. Simplify and state the restrictions. So I'm going to explain restrictions a little bit further after I've simplified. It looks like there's a greatest common factor that can come out of all three terms in the numerator. Each of them can give up a 5 and 1x. Now what's left when I take a 5x out of each of the terms is a 3x squared, a -x, and a +6. Within the brackets, that kind of looks like a complex trinomial. If you can factor that complex trinomial into double brackets, definitely do so, because you never know, it might be able to cancel out with something in the denominator. In this case though, that complex trinomial cannot be broken down, so I'm just going to leave it alone. I did, however, factor out the 5x, and it can cancel out with the 5x on the bottom. So in simplest terms, my answer is 3x squared minus x plus 6. So this is where the restrictions comes in. The restrictions means that I cannot have a denominator of 0. Any fraction that has a denominator of 0 gives you an undefined answer. So we want to state all the values of x where you get a 0 as a denominator, and we want to say x can't be those numbers. So 5x cannot equal to 0 because we'll have a problem. That means that when I divide out the 5, I solve for x, and my restrictions are x can't be 0, because as soon as x is 0, the 5x will become 0, which makes my entire denominator 0, and that's a problem. B has a little bit of a trick to it. So we're just going to start off by factoring, and it doesn't look like anything can be factored on the top, but the bottom has a common factor of 2. So I'm just going to take that out, and I'm left with 3x minus 8. It looks like the top and the bottom match. I mean, you have 8s and you have 3x's, but if you look a little bit closer, their symbols don't match. The 8s are opposite symbols, and so are the 3s. So the trick that I'm talking about is if you decide to factor out a -1, the symbols for the 8 and 3 will switch. You don't have to write that 1 if you don't want to. It can be invisible. Okay, so now the 8's match, and so do the 3's. At this point, you can cancel. And that leaves you with -1/2. So the restrictions will be taken from the denominator, and remember that this entire denominator cannot equal to 0. So let's just start solving. Divide by 2. Bring the 8 over. And then divide by 3. So the restriction for this is x can't equal to 8/3. All right, so let's just move down a little bit and we'll do the next one. These ones are going to be a little bit trickier. So we have a simple trinomial on the top and on the bottom. I'm going to break it down into the double brackets right away. And the stronger your factoring skills, the easier these will be for you. Okay, so I'm going to do this really quickly. +7 and +3 will multiply to 21 and add to 10. +7 and -4 will multiply to -28 and add to 3. And notice that I have the x plus 7 on the top and bottom, so I'm going to cancel those out, and I'm just left with x plus 3 on the top and x minus 4. To state your restrictions, you want to use the denominator over here and not over here, because we want to make sure that the x plus 7 is still considered for the restrictions. Okay, so not when you start canceling everything and then you have barely anything in the denominator. So from this step, we know that x plus 7 and x minus 4 cannot equal to 0. We can actually break those up into two different cases. X plus 7 cannot equal to 0 and x minus 4 cannot equal to 0. So in the first case, we bring the 7 over, and that means x can't be -7. In the second case, when we bring the 4 over, we get x cannot equal to +4. At the end, if you have multiple restrictions, you just want to list them out. X cannot be, and we're going to list them out from smallest to greatest. So -7 or 4. For the last one, what we're going to do is we're going to factor. These are both complex trinomials, and again, if you are very strong at factoring, this is going to be faster for you. So for me, I'm going to use a guess and check method, but you could always do decomposition. And I'm just going to quickly factor. I'm not sure that bottom part looks quite right, so I'm just going to change it a little bit. This is the guess and check method, so obviously you just guess and then you check your answer. That looks right. Okay, so something like that. All right, so I've factored at the top and the bottom, and I'm noticing again I have something common on the top that can cancel out with something on the bottom, and I'm left with 2x plus 1 over 4x plus 3. I'm going to look at the step above in order to figure out all of the different restrictions before the canceling occurs. So 4x plus 3 can't equal to 0, and x minus 5 can't equal to 0. So bring the 3 over first, -3, and then divide by 4. And on this side, bring the 5 over, so you get x can't be +5. And since you have multiples, you want to make sure that you just list them off from smallest to largest.